Now that we've introduced multi-dimensional arrays, we're going to take a look at our final version of the gradebook case study. And in this one, we'll be storing multiple grades per student using a rectangular array. So first I'm going to pull up my gradebook test class here and just show you how we set up the program and caused it to produce its output. First, we declared a rectangular array of grades with 2 dimensions, and each row of the array is set 3 grades for a particular student on 3 different exams. And we're going to use the 2-dimensional array to represent each student and that student's set of grades. So each row is 1 student, each column is a grade on a particular exam. And since all the students in a class take the same number of exams, we chose to use a rectangular array for this purpose. So down at line 21, like we did in the last version of the gradebook, we're going to create the new gradebook passing in the string for the course name and the array that contains all the grades, and presumably these would be input into the program somehow, either directly from the instructor or possibly by reading them from a file that contains the grades. We then tell the gradebook to display its message and process grades. So the basic setup of this version of the gradebook is the same as the preceding version, but now we're dealing with a 2-dimensional array of grades rather than a 1-dimensional array of grades. So let me run the program and show you the output first. And as we did in the preceding example, first we show you a summary of all the grades, but now the summary is much more elaborate. We show you the student numbers down the left side, the tests and the average for a given student across the top. So for student 1, we can see that student's 3 grades on the 3 different tests and the average for that student across all 3 exams. So one thing that's interesting about the average here is that it's not the class average, it's the average for 1 student. So somehow we're going to have to tell the getAverage method that it's going to calculate the average for just 1 student in this example, and we'll see that in a moment. We also find the lowest and highest grades for the entire class, and then we display a grade distribution as well as a bar chart. So similar output to the last version of the gradebook, but now we're dealing with a 2-dimensional array of grades. So let's go ahead and jump to our gradebook class. And as you can see in the gradebook class, we've declared a 2-dimensional rectangular array called grades. Again, this will be null until we assign it an actual array object, and we'll do that in the constructor. We still have our auto-implemented course name property. And the constructor has been modified slightly from the last version of gradebook so that it now receives a 2-dimensional rectangular array as opposed to a 1-dimensional integer array. So we take that array and assign it to the instance variable grades, and now both of the variables grades and grades array at this moment in time refer to the same array of grades. The display message method has not changed, and process grades is very similar to the last program. We output the grades first. Output grades now is going to be calculating the averages for each individual student by calling another method, so we'll look at that in a moment. We then display the minimum and maximum grades, and then we display the bar chart. So let's go ahead and take a look at output grades. And you can see here that in the output grades method, we're going to do a little bit of formatting. We say the grades are, and then we display a bunch of spaces to help us align our column heads in the output. So basically these spaces right here before the word test 1. We then display the column heads for the 3 different tests, and we're adding to the counter the value 1, so it's test 1, 2, and 3 rather than test 0, 1, and 2 for the column heads. We then follow that by displaying the string average for the last column head. So that produces this line of the output. Then we use a nested loop, a nested counter-controlled loop, to walk through each row of grades, each student, and display the grades for that student, followed by the average for that student. So take a look at what we're doing here. At line 137, we have a counter-controlled loop that counts students from 0 as long as student is less than the length of the first dimension of our grades instance variable array, and that's going to tell me the number of rows. For each student, we're going to display the word student and the student number in a field of 2. Notice once again that we're adding 1 to the counter, so student numbers will be 1 through 10 as opposed to 0 through 9 when we display them on the screen. And then for a given student, we walk through the grades in the grades array in the second dimension. GetLength1 tells me the number of elements in the second dimension, and for each student's grades, we go into the grades array at position student comma grade and obtain the grade value. We then display that right justified in a field of 8 characters. After outputting all of the grades for the current student, we then go to line 147 and tell it to display the average in a right justified field of 9 characters using floating point formatting with a default of 2 digits to the right of the decimal point. And getAverage now receives as its argument the integer called student, so we're telling getAverage which row of the rectangular array represents the current student for which we need to calculate the average. Now I'm going to right-click on getAverage and go to its definition. You can see that we receive the student number as an argument. We figure out how many grades there are in the current row. Again, the second dimension is the number of columns representing the number of grades. We then have our total set to 0, and we walk through the current row student, picking off each exam, which is our counter that's walking through the columns, and adding it to the total, and then we return the average for that one student. So that produces the initial part of the output that shows all the students, all the grades, and the averages for each individual student. Then remember that our process grades method is going to display the minimum and maximum grades, and those methods have only changed slightly from what we did in the preceding version of the gradebook. The way that they've changed is that now we're dealing with a 2-dimensional rectangular array. Now, since we're trying to figure out the smallest and largest grades of the entire set of grades for all students and all exams, we chose in this example to use a for each repetition statement to walk through the 2-dimensional array grades. So first we assume that low grade is the grade in row 0, column 0. Then we walk through all of the rows and columns using a single for each statement, picking off each individual grade 1 row at a time and 1 column at a time, checking that grade to see if it's less than the low grade, and if so, assigning it to low grade. And by the time we've reached the end of this loop, we will have looked at all of the elements in the grades 2-dimensional rectangular array, and low grade will then be returned to the caller. And getMaximum works similarly, except that we assume high grade is the first grade in the array. We walk through all of the elements in the 2-dimensional array, comparing each one to see if it's greater than high grade, and if so, assign the result to high grade each time that changes, and eventually we will return the highest grade. So pretty similar to what we did for finding the minimum and maximum in the preceding example. And then finally, output bar chart is almost identical to what we did in the previous examples. So let me go to the definition. So once again, we're going to use a frequency array of 11 elements to help us sum up all of the grades in terms of their distribution in ranges 0 to 9, 10 to 19, etc. We again chose to use a single for each statement to walk through the 2-dimensional rectangular array grades to summarize the frequencies of all the grades, and then the actual output of the grade ranges and the bars representing the frequencies is identical to the preceding version of the gradebook class. So that completes our use of the gradebook case study, and finally in this version of the example we have a true set of students with multiple grades per student. Of course, again, if this were a real elaborate gradebook class that represented all of the information for a given course that an instructor was teaching, we would probably also include student information in this class and other capabilities as well. But this gives us a sense of being able to store the grades in the gradebook and then have the functionality associated with the gradebook for processing those grades, summarizing the grades, and displaying information about the course for the instructor.